Welcome everyone to another video where we are going to solve problem number 21 from second chapter force vectors in the book of engineering mechanics written by R.C. Hibbeler, the statics part. So in this problem we are being asked to determine the angle theta for member AB so that this horizontal force of 400 pounds has a component of 500 pounds directed from A towards C, and also we are being asked to determine the magnitude of the component of force that is acting along member AB. We are being given with the angle between these two members, that is phi, and that makes an angle of 40 degrees. So let's solve this problem. It's been given that 500 pounds is directed along A towards C. Since in this problem we are being asked to determine the components of this 400 pounds along the member AB and AC, we are given that the direction of force along AC is from A towards C, like the one which you can see here, but the direction of force along AB is not given. Let's assume that it's from A to B. So when we assume this force along AB as from A to B, then in that case, if we displace any of the force component relative to the other by keeping the other force at the same position, then whether we are going to form a triangle or not. Since we are going to solve this problem using sine law, so the formation of triangle is important here. So if we assume the direction from A to B and let's say displace the force along A to C, so on displacing the force along A to C, you can see that now the closing side, which would be this side, and the force direction would be along this way. I mean the resultant of these two forces, because you know that the resultant of the component should actually be the force which have formed these components. But you can see if the direction of the resultant is this way, then it's not actually being given along this direction. It's actually being given on the positive x direction, as you can see here. Therefore, the direction that we have assumed for AB will not be like this. If it is not like this, then let's say it's from B to A. So other way around, if we have the direction of force component in the member AB as from B to A, like the one which you can see here. Now let's form a triangle. So let's move a AB force slightly upward. We are not changing its direction, but we are displacing the force along its line of action. That we can do according to, I think, law of transmissibility. And now we are going to displace the force along AC by putting the tail of AC force with the head of the AB force. By doing so, we can see that we formed a triangle. So this is FAB, this is FAC. We know the magnitude of FAC, which is 500 pounds. We know the resultant that has a magnitude of 400 pounds. We are being asked to determine the magnitude of FAB, and also we are being asked to determine this theta angle. So this theta angle will actually be this angle in this triangle. As you can see from here that the opposite angles would be same, so this angle will actually be theta. Now in this triangle, if we know any of the angle, then our calculations will become easy. We know this phi angle, which is 40 degrees. This is actually the angle between the forces along AB member and AC member. So in other words, you can say that this angle is actually 40. Since this angle and this angle is same, now we can determine the required parameters. So sine of 40 will be divided by the opposite side, which is 400. Now this could be equated to sine of theta, which will be divided by the opposite side, which is 500. So from here the angle of theta can be determined, and on doing calculations we are going to get the angle as 53.5 degrees. This is one of the answer. You can see that this angle is within this range, 0 to 90 degrees. The other thing that we are being asked is FAB. For FAB, we should know this interior angle, and this interior angle can be determined now because the summation of three angles should be 180. So 40 theta, which is 53.5, let's say that angle is x degrees, this should be equal to 180 degrees. So from here you can have the value of x as 86.5. So now you can use sine law, sine of 40 degrees divided by 400. So this would be equal to sine of 86.5 degrees divided by the magnitude of the opposite force, which is of our interest. So from here you can determine the magnitude of FAB. And on doing calculations, you are going to get 621 pounds as the other answer. So that's all from this video, where we have determined the design angle theta and also the force along the member AB, which is a component of the 400 pounds force. That's all from this video. I hope you have get an understanding of how these calculations are done. If not, then please let me know through the comment section so that I can get back to you. That's all from this video. I hope to see you in next coming videos. Till then, bye.